What do the different parts of the brain do? So there are a lot of ways of dividing a body. Talk about one of them. Okay, and so you can divide the brain into the cerebrum, or the outside of the brain. And the outside of the brain is divided up into separate parts called lobes. Okay, these lobes, they're often color coordinated, right? And they're named separate things. But when you look at the brain itself only has one color. The brain itself is only pink. Yeah, these colors are things that scientists have put onto the brain to help us understand it a little bit better. On the inside of the brain, there's a lot of parts to the inside of the brain. I'll talk about some of them here. The big one would be the brainstem. The brainstem is this part of the brain sort of inside that helps take care of functions that are important and essential to life, like breathing and your heartbeat and things like that. This little cerebellum at the end of it helps fine-tune everything, especially movement. Okay.
Yes.
So I'm going to show you a 3D model of the brain. I hope this shows up. All right, so you can see this, right? This is about a life-size model of the brain. You know, this is about as good as the brain normally is. But it's different in that someone has painted all the different parts of the brain. Okay? So if you look at this, it's going in and out here. So the red part, that's in the front of the brain. This is the front, this is the back. Okay? Front of the brain, these are your frontal lobes. Okay? The frontal lobes do a lot of things, but people think that they're responsible for a lot of the things that we think of as intelligence, right? So our ability to, learn rules, our ability to talk, our ability to communicate, our ability to behave, right? So, you're all in school, and so a big part of being in school is listening to your teachers and obeying the rules. And it's thought that the front part of the brain is what helps you do that. When you get in trouble because you disobey the rules, you decide to act up, it's because this frontal part of the brain is probably not as well developed as it's going to be when you get older. So this is a project for all of you. You're working on this. This little strip in the middle, right? So we talked about gyri and sulci. There's a division right in the middle between the red and the blue. That is the central sulcus. That is the main division between the front and the back. Right next to the division, the central sulcus, you have different strips, thin strips of brain tissue. In the back side of that strip, that is what we call sensory cortex. Now that's a part of the brain that is responsible for processing everything that you feel when someone touches you, okay? So all the different parts of the brain are represented along this blue strip of brain tissue. In front of it, that is motor cortex. So that's a thin strip of brain that's responsible for controlling your arms and your legs. Every movement that you make is controlled by this red strip of brain. So that's sort of in the back part of the frontal lobes. The sensory part is in the front part of the parietal lobe, okay? In the back here, this orange part, that is the occipital lobe. And the occipital lobe does a lot of things, but it's really mostly important for processing visual information. So everything you see is processed in this back part, in the occipital lobe, okay? And then this beige part, this yellow part, this is the temporal lobe. And there is a whole lot of stuff in the temporal lobe, but you can think of the temporal lobe as being really important for learning and memory, especially these parts at the bottom here. There are a couple of structures I'll show you on the next slide that help regulate the way that you feel, the way that you learn, the way that you learn things, and the way that you remember things, okay? And then at the bottom here, this wrinkly part here, that's the cerebellum, right? And that's the part of the brain that helps fine-tune everything, especially movements, but also regulating other things too, like the way that you think and the way that you behave, okay? And then this bottom part, remember when I talked about the brainstem? Right, so this is the part that handles all the body does to keep itself alive, like breathing and keeping control of your heart rate and everything like that, okay? So that's sort of a general orientation to what you have going on in the brain. If you split it apart into left and right, down the middle, this strip of tissue here This is something called the corpus callosum, right? So we talked about axons that connect different parts of the brain. This part, the corpus callosum, is a big, thick band of axons that connects the left and the right sides of the brain. So they talk to each other, right? If you didn't have that corpus callosum communicating, connecting the brain, one side of the body wouldn't know what the other side of the body is doing, right? So it gets pretty complicated. And something that I want to introduce here that you should know about the brain is that it's crisscrossed, right? So the left side of the brain controls the right side of the body and feels things on the right side of the body, and the right side of the brain controls and feels things on the left side of the body. There are a couple of other things that are crisscrossed too, and I'll talk about them in the next couple of slides.
For many bird watchers in North America, the northern cardinal is a familiar sight. Its bright red plumage and black mask, as well as its cheerful song, make the cardinal one of the most easily identifiable birds in the United States. Only adult males achieve the bright red color. Females have dull, red-brown feathers, but can be identified by their cheerful orange beaks and the traces of red in their wing and tail feathers. In the wild, cardinals eat weed seeds, grains, and fruits, although they may sometimes eat bugs, berries, and corn. If you live in the cardinal's range and would like to try attracting some to your yard, try putting out sunflower seeds, cracked corn, or apples. Remember to use a broad, sturdy surface, since cardinals normally hop around on the ground to find their food. Cardinals do not follow a yearly migration pattern like many other birds, so you may be able to attract them all year round. The cardinal is the official state bird of 7 states: Illinois, Indiana, Kentucky, North Carolina, Ohio, Virginia, and West Virginia, making it the most popular state bird in the country. I hope you enjoyed learning about the cardinal, and good luck finding it in your yard.
Even if you don't totally understand what electricity is, you are probably very familiar with it and use it throughout your day. When you turn on lights in your room when you wake up in the morning, when you use your electric toothbrush to brush your teeth, when you use your toaster to toast your bagels for breakfast, and of course, you used it when you turned on your computer and brought up this video. Exactly what electricity is can be kind of an abstract concept, but for now I want you to think of it as tiny particles that we call electrons. But how do these electrons make all of these different appliances work? It turns out that on their own, the electrons don't do much. But when they move, their movement generates energy, and that can power all of these different things. To talk about how this works, we are going to use a really simple example that I have drawn out here. And this is a very simple version of a flashlight or a torch. So here we have a light, and this light is attached by 2 wires to a battery. And when all of these things are connected in a loop, we say that we have an electric circuit. In this case, a very simple one. Electrons can flow through this loop, which we call an electric current. And as this happens, it can turn up lights, move motors, and heat things up. But no matter what job it's doing, we can always think of a circuit as a path through which electricity flows. There are a few things that I want to point out about this circuit. First, I want us to look at the battery. And the battery provides the power that causes the electricity to move around the circuit. And this battery, in fact all batteries, have a positive end and a negative end. And electrons are pushed out from the negative end and move towards the positive end. And the wires provide the path that the electrons can move through. Another thing you need to know about this circuit is that it only works if it is closed. If there is a break anywhere in the circuit, like if a wire was broken or not connected to the battery, the circuit wouldn't be complete and the light would no longer light up. And we could make this circuit a little bit more complicated by adding things like other lights, but we could also add things like switches. Switches are components that purposefully break the circuit, but then they allow you to open and close it as needed. So think about a light switch. When the switch is down, the circuit is broken and the light is off. But when you turn the switch on, it completes the circuit, it closes it, and this allows the light to turn on.
This is our Snap Circuit Beginner Kit for ages 5 and up. There are 12 parts that are included in this kit that allow you to make over 20 exciting different experiments. The instruction manual is full of colors and photos explaining how each part works, but more importantly, very easy photos for young children to follow each experiment. Your first project teaches you the basics of electricity and how circuits flow with switches and lights. Once you're done with that project, simply pull the snap circuits off and go to the next project. Each project will teach you something new and exciting about electricity. Visit our website at thinkways.com to see all the different levels of snap circuits available.